Now we started about OSPF network types, and we saw two types very well. Like when you have point-to-point link, the network type is point-to-point. And when you have a broadcast link, what do we mean by broadcast link? The link that runs Ethernet. It may be fast Ethernet, it may be gig Ethernet, or 10 gig Ethernet. If it is Ethernet, then the network type is called as broadcast. Two types we have seen. One with a serial link, point to point, the other with the broadcast, Ethernet, which is called as broadcast. So this broadcast type can be multi-access if you're connecting through a switch. But according to OSPF, whether you have a switch or not, it is considered as broadcast. Whether you have more than one device or not, it is considered as broadcast. So that's what multi-access. Multi-access, even this is a multi-access according to OSPF. Even though there is only one link, because it's an Ethernet link, fast Ethernet. Because it is Ethernet link, it is considered as broadcast. It is considered as multi-access. Now, why it is so important? When it is broadcast, there will be one DR, there will be one BDR. What is DR? What is BDR? If in case I got the third one, I got the fourth one, fifth one. So one of this is going to be DR, the other one is going to be BDR, and these three will be called as DR other. DR other. So broadcast will have this election DR BDR. Whereas in point to point, what is point to point? You just got two routers connected via a serial link. RA and RB. So there won't be DR BDR election between these two. There won't be DR BDR election between these two. There won't be a DR BDR election. Why? Because there is no need for DR BDR. It is just two routers. You cannot connect third router in the middle between these. You see, even we say we cannot connect. You may connect like this, another third router, but you cannot connect somewhere in the middle because it's serial wire. And if it is 10.0.0.1 here, 10.0.0.2 here, you cannot have the 10 here. It will be like 20 or something. 20.0.0.2, 20.0.0.1. It's 20 network. Here 10 network. In this, here it is 10.0.0.1, 10.0.0.2, 10.0.0.3, which means they're all in same broadcast domain. That is why the name is the network type name is broadcast 10.0.0.4. And here, even though the environment doesn't look like a broadcast environment because you got just two routers, it looks like a point to point, but still it is a broadcast because you got Ethernet. At any time you can remove one cable from here, connect a switch, and connect another cable on the other side to the router. Then you can have more devices connected to the switch with the same broadcast domain, which is not possible on the serial link. There is no switch with the serial port because that's the standard. So these two we see everywhere. Now we are going to understand why do we need DR and BDR and DR other. What is that election? What is it solving? Broadcast, it is going to elect DR and BDR. Look at this. This is what I'm trying to explain. But before we get into the understanding of DR, BDR, we also need to understand something about point-to-point. Whenever we have serial link, I said we will call it as point-to-point. Even OSPF considers it as point-to-point network type. What do we have as an encapsulation? On a point-to-point link, PPP is an encapsulation protocol. Like we have Ethernet, in a point-to-point environment, PPP is the encapsulation type, point-to-point protocol. There is also another protocol which is seen only on Cisco routers called HDLC. These are the protocol names that are used in encapsulation when we use serial interface. These are the things that encapsulates layer 2 information to the packet. PPP and HDLC are the, you will see any one of this, but on Cisco routers, you will see HDLC as default. HDLC as default. So when you have a Cisco router, another vendor, make sure you switch this encapsulation to PPP because the others are going to run only PPP. They don't have any other option. They run only the standardized protocol like PPP. So we have to change. If you are running Cisco router connecting to some other router of other vendor, we have to change the encapsulation type to PPP. Otherwise, they don't form neighbor. Otherwise, the line protocol won't come. Forget about OSPF. Even the line itself will not come. There is also another protocol, ancient protocol called frame relay and ATM. These other two protocols can also be an encapsulation type, especially when we do sub-interface. What is sub-interface? One physical interface, but we divide into multiple virtual interface. We call this a sub-interface. Whenever we got sub-interface, in olden days, we used to run frame relay, ATM. But now we don't have such protocols in usage. Anyway, that is also a point-to-point. Though it is a sub-interface, it's a point-to-point sub-interface. Next is the election is not needed because it is just two router. See, when there is two router, why there is need for an election? For example, in a project, there is only two people, just two. When you have only two to do a project, why there is need for a manager posting and assistant manager? There is no point in it. Just two routers. They need to understand each other very well, fully synced to do the project. That's all. They both need to show their involvement. So no DR, no BDR. DR stands for designated router, which is like a team leader for a project. BDR is like his assistants in that project. His assistants. So when there is a team leader, will the assistant speak? No, should not speak. But whatever team leader can receive from the team members, the assistant also will receive because he is an assistant. When team leader fails to come for office one day, the assistant will be will be up to date to solve any problem in team leader's absent. Same way the DR-BDR functions, but there is no need for DR-BDR because it's point to point. There are two routers. Both the routers are fully synced. If in case one router goes down, the other router will know very clearly that the other router has gone down. And if one router receives an update, the other router will be informed about the update because it's just one neighbor, point to point. Alright, so you need not to configure this as a network type point to point. We don't configure this interface, the port, the serial interface as point to point. It is auto-detected. If you are running HTLC or PPP, OSPF is going to say you are having point-to-point network type. And if you are running Ethernet, that will also be auto-detected, and OSPF will say you got broadcast type. Network type is broadcast. It's auto-detected. Fine. And now, because there is no designated router, the other address 224.0.0.6, which is only meant for designated routers, will not be used because there is no designated router for a point-to-point network type. OSPF packets are sent using multicast address 224.0.0.5 only. 6 is not going to be used. So what's the multicast address of EIGRP? We learned 224.0.0.9. 9.
Yes, sir.
No.
Is it 10?
Correct. RIP version 2 is 9.
9. Yeah, because you said 9, I thought, okay, how can you be wrong?
Oh, no, not like that. Sometime, some age factor, something like that. I miss. I wrongly say sometime. So 9 is RIP. EIGRP is 10. And OSPF is 5. If it is point to point, only 5. If it is broadcast, both 5 and 6 are going to be used. The 6 is the address to which designated routers will be receiving packets. So if anyone wants to send an update, they will send only to designated router using this address. No others can receive except the designated router. That's what you see here. You see, among 5 of this router, you got only one designated router. And then one backup designated router. If you see the arrow mark between DR and PDR, it shows that they are fully synchronized, the black arrow. Whatever DR
So
knows.
this one, will be within an area, right?
Yeah, yeah, yeah.
OSPF,
Correct.
DR, BDR, yeah.
This is within an area, and you may see more than one within an area. It depends on how many broadcast domain you have. See, I can have in an area a point to point, or I can also have another switch here. Now, in this also there is going to be one DR and BDR, like you have here. In this you don't have DR BDR because it's point to point. So in an area, we may have more than one DR and BDR because in each area there is no like only 5 broadcast domain. There is nothing like only 5 LAN segment or 4 LAN segment per area. For each LAN segment, this is what one LAN segment. You got one switch through which all these guys are connected. This is one LAN. We don't know how many LANs in an area. There is no fixed number. So if someone says how many DR and BDR in an area, how do we know? We don't know. Unless someone provides a detailed picture of serial wires and LAN connections within an area. We cannot say that. So, designated router and backup designated router is needed only when we have more than 2 devices. Whenever Ethernet is there, even if you have 2 devices, there will be DR BDR because according to the OSPF, when someone runs Ethernet, there are chances to have more than 2 router. They might have connected through a switch like what you see in the picture here. So, to avoid duplication of update, to avoid loop which is caused because of duplication of update, there is going to be a DR and BDR. For example, in a team of 5 members, there's a team for a project and there are 5 members in the team. In that 5 members team, if one has got some update to inform others, they should inform it to leader. And it can also be CC to an assistant leader so that both will be aware of the new update that you are giving. And then this team leader, designated router, that's what I mean here, team leader, The team leader will see whether this is an advertisement, this is an update that I can share with others, and it shares to others. If you don't have DRBDR, which means there is no leader in the team, then everyone will give update to all others. There are chances that the update that I gave you, the other guy also gives you, and you think that it's with both of us, which is not true. That is going to cause loop. Because according to you, there are two paths to go to reach a destination, one via me, one via other. But the other guy actually forwarded what I sent, which you do not know. So in order to avoid duplication of update, in order to avoid loop, we need a leader. We need a designated router. And in case if the designated router goes down, we need a backup designated router. Right, so designated router and backup designated router are elected based on the router ID. First, actually, to look for priority. If I set priority here 10 and here 5, and these are by default 1, so I did not configure any priority on these three routers down here. Only on the above two, one has got high priority, the other one has got a little lower. The one with the high priority becomes the DR. If in case you don't have priority set, then the priority on all router is 1. The priority on all the router is 1. When it is 1, then how the DRBDR is elected based on the router ID. We saw in the previous class there is going to be a router ID for every router. There will be one 32-bit unique identification. That identification is compared. The router with the big identification, the router with the big router ID, big, becomes the router DR, designated router. The next biggest IP address router will become the BDR. See, they send a hello packet every 10 seconds. So every router knows which one has got the biggest router ID. Now, in order to send an update to DR and BDR, we got a special address. So when this router got some new update to send, information to send, it leaves this address to send so that only these two guys can receive it. No others can receive it. And BDR will not advertise it when DR is available. BDR has got no authority to advertise it. When there is a DR, only a DR should speak. BDR should be silent. BDR will be receiving every changes that's happening. BDR will be receiving all the updates that is sent to 224.0.0.6. So not only DR learns it, even BDR learns it, but the difference is BDR will not speak. Only designated router only can advertise, can speak. Now, what is that is used to speak to everyone? To speak to everyone, 5. 224.0.0.5 is used. So when this router send update to 224.0.0.6, it goes to this guy and this guy. And now DR takes the update and uses 224.0.0.5 to inform the rest. Packet from DR to all router is using 224.0.0.5. Do you have any question on this page?
No, sir.
Oh, this is what I was talking about. You see, the priority is higher, so that router on the top left has become the DR. The next router with the lower priority becomes PDR. So what is the tiebreaker? Router ID. Yeah. What about this 0? See, router C has got priority 0. Is it default? Is the priority 0 default? No. Priority 1 is default, which means by configuring 0, we are saying do not participate in election. Never participate in election. Do not participate in election. That is what router C priority 0 means. By default, it was 1. Now someone has changed it to 0 so that this router will never participate in election. And the default is 1. The top two routers are configured as 3 and 2 so that they will take the role of DR and BDR. This is the command to set priority under the interface. See, in order to set the priority, you need to go under the interface and say IP OSPF priority and the priority number. See, 1 is default priority in broadcast. You can go up to 255, and 0 means the router cannot be a designated router or be a backup, meaning it cannot participate in election. How can it become a DR or BDR? Okay, so the next topic is the 5 modes that we have in a NBMA environment. NBMA environment, non-broadcast multi-access environment, is nothing but you got some technology like this in the middle. Between these 4 routers, we got a frame relay. That was the latest of these 3, and all these 3 are now no more in industry. When you have any one of this in the middle, you need to know these 5 modes that we are going to learn. But when we don't have them, why do we learn it? There's one place where I may use this to avoid the BDR election. That is why we are learning. All right. And these 5 modes are not for every vendor. These 5 modes are only for these 5 modes are not for every vendor. These 5 modes are only for Cisco. These are the 2 industry standard. So according to other vendors, only these 2. These 3 are Cisco's idea. So the 5 modes are non-broadcast, point to multi-point on broadcast, broadcast, and point to point. Under NBMA, this is broadcast. This is not the same broadcast which we saw. This is under NBMA, broadcast. Under NBMA, point. So we are going to see these differences.